Hello everyone. In this video we will be focusing on the investigation of gas phase in buildings.
First off is the introduction. Explosion is a phenomenon resulting from the sudden release of energy with the potential to produce shock or blast waves and missiles, where both of these can cause remote damage. The ways in which energy can be released suddenly and the type of damage caused in general can be broadly divided into three categories, which are detonation, deflagration, and hydraulic or pneumatic failure of pressurized containers. Detonations are caused by high explosives and certain unstable solids and liquids. The detonation of a high explosive is caused by a very rapid reaction process taking place in the material, which leads to an almost immediate rise in the pressure at the source of the reaction. This, in turn, will set up a shock wave, which travels outward at a speed greater than that of sound in the air. The shock wave causes shattering and crushing of objects nearby. At the same time, local effects of heats are usually present. Lastly, remote damage may result from the interaction of a blast wave with neighboring structures. Next is deflagration. A flame propagation is caused by combustible gases, vapors, dust, and aerosols of combustible liquids. These flames travel at a speed slower than the speed of sound in the air. Combustion reactions in the flame will cause a rise in temperature and an increase in the number of molecules. This causes the expansion of the gases. This expansion will cause the pressure to rise until the weakest element of that structure fails. This will relieve the pressure and allow the products of deflagration to vent to atmosphere. Stored energy, for example in steam reservoir, pressurized air containers, and chemical reactors containing a liquid under pressure, can be released suddenly if the container bursts. Higher rates of release of energy means that it is due to the failure of structures containing the compressed gas and superheated liquids. The bursting pressurized vessels generate blast waves that can cause serious damage to a building in which the vessels is located and to a neighboring structure. The majority of explosions in buildings result from a deflagration.
There are four important properties of combustible gases, vapors, and dust in admixture with air, which are flammability limits, stoichiometric mixture, factors influencing the accumulation of gas leaking into compartment, and lastly, flame speed and burning velocity. Firstly, flammability limits. The mixture of gases, vapors, and dust are capable of propagating a flame only when the concentration of fuel in the air lies in flammable range. There are two limits in flammable range, which are lower explosive limit and upper explosive limit. For the fuel or air mixture whose composition is not within the range, they will not propagate a flame under normal atmospheric condition. Stoichiometric mixture is applied to fuel that is in gases or vapor state. This happens when sufficient oxygen is used to balance the process of hydrocarbon fuel converted into carbon dioxide and water. For stoichiometric mixture, percent concentration by volume of fuel in air usually lies closer to LEL than to UEL. There are three factors that influence the accumulation of gas leaking into a compartment. Firstly, gas density. Gases that is dense than air will form mixture between point of leakage and the ceiling. Next, the condition of leakage. Finally is the ventilation. In ventilation, the temperature difference and effects of wind will influence the natural ventilation. Flame speed is velocity at which the flame front moves with respect to stationary observer. In combustion process, the rise of temperature will cause expansion of flame. Maximum laminar flame speed of saturated hydrocarbon lie approximately in range of 3.5 to 4.1 meter per second. Burning velocity can be defined as velocity which the flame front moves relative to the unburned mixture of fuel. The burning velocity increases as fuel content increases from a composition close to LEL to a composition near to UEL. When the burning velocity increases, the temperature also increases. Lastly, the burning velocity increases when the pressure increases.
Development of pressure. Expansion of gases causes by rapid rise in temperature. Flame front move through a fuel or air mixture causes the expansion of the gases and then causes the pressure to rise. Pressure information transmitted omnidirectionally. There are two main pressure. The first peak is PV, pressure at which the vent is removed. The second peak is PM, maximum final pressure. Based on the figure, there are 4 points that should be noted for variation of pressure with time for an idealized vented gas explosion. The effect of a pressure pulse on a building structure, usually to determine a range within which is the likely maximum overpressure lies. The inertia of a structure or structural element significant influence on magnitude of peak pressure during deflagration. It means higher peak pressures occur for structures which have a higher inertia. The effect of gases explosion in buildings. If window glazing is broken, this is because the breaking pressure of the glass is exceeded. Besides, measurement of distance travelled by the glass fragments provide useful indication of the peak pressure generated by the explosion. For walls without returns, cracking started soon after the tensile bending strain exceeded the pre-compressive strain. The failure pressure of brick wall determined from static pressure test, representative failure caused by a smooth pressure pulse generated during gas explosion. The sudden failure of a pressurized enclosure creates a pressure disturbance called classical shock wave profile. Diagram shows the decay of pressure with time of shock wave, where there are peak overpressure, positive phase and negative phase. Rough action involving low energy density source. The passage of the shock wave may crack the windows and begin to fail inwards. Before they have time to move into the building, the pressure drop outside the building due to the reversal of the process. Significant amount of glass end up outside the building. It often found to be bowed outwards, for example, towards the blast source.
The scene investigation. The purpose of the scene investigation is to ascertain general category source of energy. If a gas explosion, determine whether gas was lighter or heavier than gas. Estimate the range within maximum explosion overpressure and close lies. Identify source and size gas leak. Determine the probable reason of leak and identify the source or potential of ignition. Next, for preliminary investigation. Before approaching the scene, investigators should think about the general circumstances of the incident. Witnesses are fallible. Power of observation and recollection may deficient. Can be reduced by taking the witnesses in position where they observed the scene originally. Witness will provide information about state of peril to the incident, routines, procedure, methods and description of event that leads to the explosion. During the investigation, the crime scene should be photographed in colors or videotapes. Include peripheral damage of buildings. Written notes, commentary should be made of photograph subject. Scale plan, sketch what was happened in a building or the situation. Make sure to take notes of everything inside the scene. Third, investigator should focus more on materials of construction buildings, location of the main gas and service pipe, routing of redundant buried gas pipe work and consumers, gas pipe work and original disposition appliances. Presence of external wall and fuse, identify the source of fuse. Next, systematic and more detailed examination. There are 6 of them. The first one is identify the origin of explosion. Second, nature of the fuel. Third, identify the fuel. Let's continue with the fourth one, which is fire associated with an explosion. Fifth, source of leak. Lastly, source of ignition. Lastly, the final stage of the investigation involve application of theoretical analysis, calculation of result of secure examination. Determine pressure at source by estimate the degree failure. Lower limit overpressure, example, glass window did not fail during explosion. Incipient failure of structure give more useful indication of explosion overpressure. Independent methods can be known by measure the maximum distance of glass fragment travels. How to measure explosion overpressure? By determining the maximum distance of glass fragment travel, determine the blast damage that causes neighboring buildings. Lean fuel produced when the heat is minimum at low heat. Low overpressure fuel with rich mixture. If presence of gas leakage, measure the leak rate. and estimate the gas required for the damage. If the volume falls between the leakage point and ceiling, thus the gas is less denser than air.
That's all from us. Thank you for watching.